Grade 8. In today's lesson, I'm going to further explain speed-time graphs and do some exercises with you on how to draw them, how to plot a speed-time graph, and how to calculate distance from speed-time graphs. This topic needs a lot of practice in order to grasp the idea and be comfortable with speed-time graphs or distance time graphs. You have to answer as many questions as you can. So I have a sheet with me, a worksheet with some questions on speed time graphs. I'm going to answer the first two questions with you to demonstrate how to do them. Then you'll have the remaining questions as a homework for next lesson. You can either print out this worksheet if you have a printer available. If not, you can answer the questions on a Word document. So let's start with question 1. On the graph paper grid, sketch a speed time graph for the car whose journey is described here. The car sets off at a slow, steady speed for 20 seconds. Then, during a time of 10 seconds, it accelerated to a faster speed. It traveled at this steady speed for 20 seconds. Then it rapidly decelerated and came to a halt after 10 seconds. So, what we need to pay attention to is the units used in the story or in the journey and the time spent during the journey. Here, they have mentioned the time in seconds, but there was no mention of the unit of speed. So, first we have to label our graph. Time in seconds. And this is our speed. They didn't give us values of speed, but they said that the first speed was slow, then it became fast. So you can choose whatever speed you want. The time limit of the journey. The journey consists of 4 parts. The first part took about 20 seconds. So the car sets off at a slow, steady speed for 20 seconds. The second section, during a time of 10 seconds, it accelerated to a faster speed. So the second section lasted for another 10 seconds. It traveled at this speed for 20 seconds. So 20 plus 10 is 30, plus 20, 50. Then it rapidly decelerated and came to a halt after 10 seconds. Another 10, this is 60 seconds. Okay, so remember that we said that the speed time graph represents the speed of the moving object. So the graph line tells us what's the speed of the object. The first section, the car sets off at a slow, steady speed for 20 seconds. So let's divide the x-axis. We need to divide it into 60 seconds. So every 2 grids, we will divide it into 10 seconds. So 10, 20, 40. Okay, remember that we need to use more than half of the graph paper that we have in the question. Okay, the car sets off at a slow, steady speed for 20 seconds. It immediately starts at a steady speed for 20 seconds. This means that it did not accelerate slowly as it started. From the beginning, it started at a steady speed for 20 seconds. So a slow, steady speed, so it's slower on the y-axis. So let's say that it started at this steady speed. It sets off for 20 seconds. So this steady speed lasted for 20 seconds. So the first section of this journey is a steady speed for 20 seconds, a slow, steady speed. Then during a time of 10 seconds, it accelerated to a faster speed. So now from this point here, it started to gain speed. It started to speed up, and this took about 10 seconds. So we need now to increase the speed or accelerate in a time of 10 seconds, from 20 to 30. Let's say that the car's speed reached this point in 10 seconds. So we plot a point between 30 and the new speed. And this line here, it represents the speeding up of the car during this time. Speeding up means the acceleration of the car during these 10 seconds. Remember that acceleration is the change of speed in a time unit. The third section, it traveled at this steady speed for 20 seconds. So when it reached this new speed, the faster speed, it continued to travel at this steady speed for 20 seconds. So the speed is not going to change as time passes by. So 20 seconds is 50 seconds now. 30 plus 20 is 50. So it continued to travel at this steady speed for 20 seconds. See how the line here is horizontal and straight. Then it rapidly decelerated and came to a halt after 10 seconds. Came to a halt means came to a complete stop. Decelerated, it means that it slowed down. So now it's going down in speed. The speed is slowing down. So it took this slowing down from this speed to zero speed took 10 seconds. So 50 plus 10 is 60 seconds. And the graph line will look like this. Now look at the graph lines. When it traveled at steady speeds in the first section and in the third sections, the graph line looked as a straight horizontal line. You don't have to memorize these characteristics of the graph line. You have to understand them. So a straight horizontal line means that the value on the y-axis is not changing. The value here on the y-axis is speed. So the time is moving, but speed is not changing. So what we will have is a straight horizontal line, and this represents a steady speed in speed time graphs. When the line is straight and sloping upwards, this means that the object that's moving is gaining speed. So the values on the y-axis are changing as time passes by. So this will be represented as a straight line sloping upwards. When the object is decelerating or slowing down, the values on the y-axis now are decreasing. So the line will go down to reach zero if the object is going back to the stationary situation. Question 2. The table shows how the speed of a car changed during a section of a journey. So we have a table, speed meters in seconds. The speeds are 0, 9, 18, 27, 27, 27. Time in seconds, 0, 10, 20, 30, 40, 50. Draw a speed time graph to represent this data and use the graph to calculate the distance traveled by the car during the journey. Okay. In order to draw the graph, we need to study the data in the table. Time is given in intervals of 10 seconds. So 0, 10, 20, 30, 40, 50. We have to divide the x-axis from 0 to 50, and we have to use more than half of the graph. The values of speed are given in multiples of 9. 0, 9, 18, 27, 27, 27. So we can divide the y-axis into multiples of 9 as well. Okay, so the x-axis, label it time in seconds, and the y-axis speed in meters per second. So we will divide the x-axis into 10 seconds, 0, 10, 20, 30, 40, 50, and 60. And the y-axis into values of 9, 9, 18, 27. Now we need to plot each point on the graph. The first point is between 0 time and 0 speed. So it's right here. When the time is 10 seconds, the speed became 9 meters per second. 10 seconds, 9 meters per second. 20 seconds, 18 meters per second. So we plot a point between 20 seconds and 18 meters per second. When the time was 30 seconds, the speed became 27 meters per second. Now for the next 20 seconds, for the next 20 seconds, the car continued to travel in the same speed, 27 meters per second. So when the time was 40 seconds, the speed was still 27. When the time was 50, it was still traveling at 27 meters per second. Notice the first section of this journey. The speed of the car was increasing every 10 seconds in the same value. So every 10 seconds, the speed increased 9 meters per second. The second 10 seconds, another 9 meters per second. The third 10 seconds, another 9 meters per second. This is what we mean by a steady acceleration. So the increase in the speed of the car is the same every time unit. Now, this will show as a straight line sloping upwards. And this is what we mean by steady acceleration. If you look at this graph line and you were asked to tell what's the speed of this car in this section, you say that this car is accelerating, meaning that it's speeding up uniformly because the line is straight and sloping upwards. Now in the second section of the journey, the car continued to travel in the same speed, which is 27. So the line of this section will appear to be straight and horizontal. And this is what we mean when we say that a steady speed in speed time graphs is a straight line horizontal. Now this is the only part of the journey that we were given and that we can represent. This is how we draw it. Now let's move to calculating distance from speed time graph. From last lesson, I said that in order to calculate the distance from speed time graphs, you need to calculate the area under the graph. What do we mean by the area under the graph? All the area under the line is the distance traveled in this journey. Let's look at the area under this graph. How can we divide it? The area is, it ends here. Okay. This shape here looks like a trapezoid. How can we calculate the area here? But we can either use the formula for the area of trapezoid, or we can divide the area into two shapes that are a rectangle and a triangle. So calculating this area here will give us the distance traveled by the car. Okay, I will do it in both ways. I will do it by calculating the areas of the triangle and the rectangle and then adding them up. And I will do it by calculating the area of the trapezoid. So let's call this area 1 and this is area 2. Okay. So distance equals area under graph, which equals area 1 plus area 2. Let's calculate each separately and then add them up. Area 1 is the area of a triangle, which equals half base multiplied by height. Now the base is on the x-axis. This is the base of the triangle, and this is the height of the triangle. The base starts at 0 and ends at 30. So the value of the base is 30 seconds. So it equals half multiplied by 30 seconds multiplied by the height, which is from 0 to 27 meters per second. And the answer is 405 meters. Remember that we put the units as they are seconds and meters per second. You eliminate second with second and the value that remains is in meters. Now area 2 is the area of a rectangle, which equals the width multiplied by the height. The width of the rectangle starts at 30 seconds and ends at 50. So the width of the rectangle is 50 minus 30, 20 seconds, multiplied by the height, the same height, 27 meters per second, and the answer is 540 meters. Now the distance traveled equals area 1, which is 405, plus area 2, 540 meter, and it equals 945 meters. The same question, I'm going to calculate it or calculate the distance traveled by calculating the area under graph as a trapezoid. So the area under the graph is this area. This shape is a trapezoid. The formula of a trapezoid is, or the area of a trapezoid is half base 1 plus base 2 multiplied by the height. So the distance traveled here equals area under graph, and it equals the area of trapezoid. Half base 1 plus base 2 multiplied by the height. So what's base 1 in this case? It's from 0 to 50. It's 50 seconds. 50 seconds plus base 2. Base 2 starts at 30 and ends at 50. So it's the difference between them. 50 minus 30, 20 seconds. Multiplied by the height. The height is from 0 to 27 meters per second. equals half multiplied by 70 seconds multiplied by 27 meters per second. Seconds goes with seconds, and the answer is 945 meters. So whichever you wish to use, you can use either the area of a trapezoid or divide the areas into a rectangle and a triangle. You will have the same answer both ways. So the remaining questions are questions of calculating distance from distance time graphs. I want you to study the lessons, this lesson and the video that was posted before about speed time graphs, and try to do them on your own for a homework for the next class. Thank you very much.